You know, some math problems feel like they were just invented for homework, right? But what if I told you that one of the most common equations in algebra is actually an ancient puzzle, a mystery that took humanity 4,000 years to solve? Okay, let's dive into this. First, take a look at this. What you're seeing here is a Babylonian clay tablet. It's from around 1600 BCE. I mean, this is a genuine piece of ancient history, covered in these mysterious-looking symbols. Now, how in the world could that ancient artifact be connected to this? Yep, the modern quadratic equation. That is the mystery we are going to unravel today. How did we get from that clay tablet to this universal formula? And let me tell you, the answer is an absolutely incredible story of human ingenuity. So to get to the bottom of this, we have to go way, way back to the very beginning, with a problem that's literally thousands of years old. Seriously, we're talking over 4,000 years. Just think about that. That's how long people, mathematicians, merchants, everyday thinkers, have been wrestling with this exact same challenge all across the globe. So, how did they even start? Well, the first people to tackle these problems didn't have algebra, not like we know it. They used what they could see and what they could touch, shapes. And check this out. This map shows something I think is just fascinating. This wasn't one person's discovery or even one culture's. From Babylonia to Greece to India and China, different people were all working on similar problems completely independent of each other. It was this shared human challenge. So let's go back to those Babylonians for a second. Think about it. No X, no Y, no plus signs. They didn't even have an equal sign. So how on earth were they solving these really practical problems, like figuring out the area of a field or the size of a square? Well, the answer is they thought in pictures. To them, a problem wasn't a bunch of symbols on a page. It was a physical thing, a series of cut and paste actions they could literally imagine doing. And this is how they did it. It is so clever. Imagine you have a rectangle. You'd literally cut off the extra bit that makes it not a square. Then you'd slice that piece in half and paste it onto the other side. What you end up with is a new, almost complete square, and from there, the answer was suddenly within reach. It's a physical way of literally reshaping the problem itself. And for centuries, that was pretty much it. This cut-and-paste geometry was the best tool they had. But then, in the 8th century, something massive happened over in Baghdad's House of Wisdom. The world was about to take a giant leap, from shapes to symbols. The Persian mathematician Al-Khwarizmi introduced this revolutionary idea he called al-jabr. Now, that's an Arabic word that means restoration or completion. He was talking about restoring balance to an equation by doing the same thing to both sides. And if that sounds familiar, it should. It's literally the root of our word algebra. I mean, what Al-Khwarizmi did was a total game changer. Instead of these one-off geometric tricks for every single problem, he created a system. He realized that all these problems could basically be sorted into 6 main types, which you can see right here. And for each type, he wrote a set of rules, a procedure to solve it. This was the birth of algebra as a universal toolkit. So that incredible historical journey brings us to today and to the payoff. All that history has given us these incredibly powerful and efficient tools to solve these equations. So let's talk about one of the most common methods you'll use, factoring. You know, I absolutely love this analogy. Factoring is like trying to find which ingredients went into a cake to make it so delicious. See, multiplying out an equation, that's the easy part. That's like baking the cake. But factoring? That's working backward. It's trying to figure out the original recipe. And yeah, it can be a little tricky. But thankfully, there is a reliable recipe for this too. It's called the AC method. The puzzle is actually pretty simple. You multiply the first and last numbers, A and C. Then you just have to find 2 new numbers that multiply to give you that result, but add up to the middle number, B. Once you find those 2 magic numbers, the rest of the process just kind of unfolds step by step. All right, so you've got the method. But like any powerful tool, there are a few common traps people fall into. But hey, if you know what they are, you can avoid them every single time. Okay, this one right here is probably the single biggest, most common mistake, squaring negative numbers. Let's say B is -7. It's so easy to just write down -49. But you have to remember you're squaring the entire thing, the negative sign included. So -7, in parentheses, squared is +49. It feels like a tiny detail, but it changes everything. And here's the other big one, stopping too soon. You do all this hard work factoring, you get your answer, something like x minus 5, x plus 3, and you think you're done. No, you're so close. Don't forget the final crucial step. Set each of those little parts to 0 to find the actual solutions. So x minus 5 equals 0 means x is 5, and x plus 3 equals 0 means x is negative 3. You gotta finish the job. Okay, so let's just take a step back and look at the whole picture here. From a scribe in ancient Babylonia carefully etching marks into wet clay, to a student today plugging numbers into a calculator. What an absolutely epic journey. This timeline just puts it all into perspective, doesn't it? It's like a great relay race of human knowledge. The Babylonians started it off with their shapes. Then Al-Khwarizmi took the baton and gave us a system. Centuries later, Renaissance mathematicians like Cardano started playing with weird new ideas like imaginary numbers. Then Descartes came along and connected it all to graphs, giving the numbers a picture. Every single step built on the last one, leading to the tools we use in everything from physics to finance today. And that brings us to a final thought. You know, it's easy to look at math as this book of ancient finished rules, but this story proves that's just not true. Math is a living, breathing story of discovery that we're all still writing. I mean, this one equations chapter took 4,000 years to get here. So it really makes you wonder, right? What great mathematical story are we in the middle of right now?